Well, Merry Christmas, everyone. I figured we'd do a update, and I'm getting asked a lot of questions as Jeff is finishing up the motor. So I wanted to cover what we did here. So you'll remember about a year ago, I came across this vintage inlines head. It is based off the classic inlines head, and Matt Cox made a run of these. Um, This, I believe, is serial number 25, but I could be wrong. I've never actually seen this head in person. It was found in Georgia. Somebody had bought it new with a bunch of new parts. That's what this photo is here, actually. The guy had an oil pan and a header and stuff. I gave the header to somebody else, but there was just a whole host of parts that came with it. So, anyways, we did come across this in Georgia. I think Colin found it, and we kind of snatched it up pretty quick. You know what I said was, I'll buy it, Colin. I said I don't know what the hell we're gonna do with it. I said, but I'll front the money and let me get a hold of it. Colin's already got one of these, so I said, maybe I should do a build with it. Maybe I should sell it. I don't know, but I just wanted it. I wanted it in our quote our safe hands as far as the Vintage Six forum goes. So I did pick it up. It was not cheap, but it was in Georgia, which worked out really well because that's where John is, another admin on the Vintage Six forum and a good friend of mine. So I called up John and I said, "Hey," I said, "the guy's about an hour north of you. Would you mind going and picking it up?" And John ran up and grabbed it for me. He once he got it home, he kind of split up some stuff. Sent I think Colin got the header. I think I might have sent Paul something. Anyways, but we did ship it just directly to Jeff. So yeah, we got the manifold, the head. That's really the main, most important part. So, anyways, like I said, we shipped it up to Jeff, and I said, Jeff, I want you to go through the head. I want you to port it. I don't. At the time, I wasn't positive what I was going to do with it, but I just wanted to get it to him. By the time it arrived at Jeff's, I had thought about this a little bit, and I remembered that I'd given Jeff my old short block, which was actually the original block out of my car, and it matches by date code. It's by all rights is the correct block for it. So I asked Jeff. I said, "You still got my short block?" And Jeff said, "Yep, I still got it." And I said, "Great." I said, "Set it aside for me." I said, We're gonna do another build. It's easier to just do a swap." So, anyways, Jeff got the head, and we kind of immediately started seeing the issues with it. So here you can see this is the combustion chamber, and I want to pause here for a little bit on this and show you. If you look at the intake and exhaust valve, they shouldn't be inset like they are. The valve should be proud of the combustion chamber a little bit. It's called valve shrouding, and you don't want that. It can actually cause the valves to run too hot, and you end up with a burnt valve. It's one of the problems you can have. Now, the reason that this is the way this is, because whoever did the finish work on this head was not very good. You do not want your seats set that deep, but that's exactly what they did. They cut the seats too deep, and it could be because the valve height was wrong. It could have been the valve pressure was wrong. I'm not really sure why they would have done this, but they cut them too deep. You really don't want to start taking seats out of an aluminum head. Every time you do it, it gets a little bit more loose. It can become problematic. You have to get oversized seats. So what Jeff opted to do after we talked about it here, and actually I want to show you another shot too of it. He just used the gasket just to show you how far inset the valves are. So what he did was he said, "Look, well," he said, "I'll blend the bowls in, and we'll just make the combustion chambers larger, and we'll just mill the head down. There's plenty of material. It's a brand new head." So we went ahead and did that. Here's a shot with the valves out. You can see how far down the the seats are. It's just all wrong. And you can also see, if you look closely at the intake, which is on the top, the larger valve, you can see that the seat is offset in the port. So it's just sloppy. I think the casting's fine, but the machine work was sloppy. So Jeff cleaned all this up. He ported it out, and made it real nice. That's what this photo is right here. Is after he cleaned it up. So you can see there was quite a bit of work done in there. He had to really clean up the bowls. He had to blend into the seats. And then, of course, he had to recut the seats after that, and recut the valves. He did a 3-angle valve job on it, which is fantastic. And you can also see he ported all of the ports. Additionally, and I didn't include any photos of this, but he did flow the head against one of his 2V conversion heads. We got some numbers. Yes, the vintage inlines, classic inlines head definitely flows better. Obviously it will, just based on the improved design. But it wasn't shockingly more. It's definitely better. I think one of the biggest benefits is the combustion chamber size and shape is much more modern with these. So moving on, then we had to start talking about multi-port fuel injection. So this is a picture of a cross section of the classic inlines head, which is the same casting. It's the same head. I took this and I imported it into AutoCAD and did a little bit of math in here just to understand what the optimum injector angle is. If you look at this cross section, one of the things that's really kind of crappy about where the injector bungs are, they're at a 63-degree angle to the port, and you really don't want that. You want the injector pointed at the back of the valve. That's most optimum. So we played around with some numbers here. You can see I played with 27, 20, 30 degrees. The problem that you start running into is because the boss is at a 63-degree angle. You can only bore it so far. So Jeff and I actually ended up, it's not on here, but we ended up putting it at 14 degrees. That was the best angle that we could get with the injector depth being correct. You don't want the injector shrouded inside of the bung too far. So we went with 14 degrees. Jeff had to spot face those. This is a picture of him setting it up in his mill. And here's another picture of him starting to play around with the angles. This was before I did it in AutoCAD, actually, and I sent him what I thought the best angles would be based on what I could CAD. But anyways, so here's a picture. Here's where he spot faced them at 14 degrees, and he pilot drilled them. This is a picture of the first one being drilled right here. So that's a pilot drill size there, and we wanted to make sure we had it right, so we did one first, and if we screwed it up, we could always repair it if we had to. But anyways, it came out all right. This is a picture of him setting up the spot face. I've actually got these out of order. But anyways, use an end mill to spot face them. That way it's flat to the right angle when you go to bore them. Here's a picture of another picture of him boring them. The injector bosses, boy, can't talk as usual. Another image of the first pilot hole drilled. Here's a picture of the injector fitting a fit up test for the injector in the rail, or in the boss. Here's a picture of them all bored. So the way that these work in this image, you can sort of see it. The pictures aren't great because they're just whatever Jeff took on his phone. You have to bore it for two different sizes because the injector is stepped. That's what stops it from going any further down in. So there's actually a smaller bore, and then there's a larger counter bore on the top. So that's that. So he hasn't sent me any pictures of the rail yet, but I know he's worked on it. Nothing really magical there though. Same thing. You got to bore it for the injectors. On the rail side, I just used some stock rail available from Holley. It's just a 36-inch piece that gets cut to size. I sent him the right parts to put the fittings in the end. By the way, we will not break in this engine with the fuel injection. The whole point is to have Jeff run it on his stand and make sure that we get broken in on a carb. MPFI is going to be really experimental with this thing. I don't want to be breaking a cam in with an experimental EFI system on a 200. That's just not wise. I don't want to be flattening a cam. So Jeff's doing it on his stand. Here's a picture of the my original block out of my car. So this is it. Him finish honing it. So it's now 40 over. It was 30 over. He punched it out another 10. That's about as far as you want to go on these 200 blocks. Some people, I think, probably maybe you could go 60, but I think that's pushing it. I don't even think they make 60 pistons for it. This isn't like a Chevy. You can't go 60 or 80 thousandths. The walls just aren't thick enough. 40 is about it. This will be this block's last build, basically. So moving on, it's kind of a big jump here. Here's a picture of it assembled. So the thing that we're battling right now, and here's another image of it sideways. It turned out really beautiful, didn't it? The thing that we're battling right now is one of the tricks that we're going to play with this. By the way, we're putting a Clay Smith 264 in it on 110. Which is actually a little bit smaller than everybody is. When I say everybody, I'm talking about Clay Smith, I'm talking about Comp, I'm talking about Iski. They all said to go to a 274 advertised duration. I've got power brakes. I want idle quality out of it. So we're going one step smaller than the cam manufacturer. All the cam manufacturers are recommending, actually. They're recommending it out of peak performance. So we're going to lose a little bit on the top end, but that's okay. We'll pick up some on the bottom end. It'll run pretty well. But we're going to play a little trick on this. So the hardest part about this, and it's what Jeff is still working on, he's having some issues right now, actually, with what we're trying to do. The normal rocker ratio in these things is 1.5 to 1. You can get 1/6 rockers. But we're actually going to go with some FE rockers, and FE rockers are 1.73 to 1, which is pretty awesome. So we can kind of artificially give it more lift without putting a bigger cam in it. It's a trick that's been played many times. It's something that's very common in small and big block Chevys. Very common trick to play, but you can buy the parts for it. FE rockers, the bore size for the shaft is much larger than it is in a 200. So Jeff is boring out the FE rockers, and he's actually making bronze bushings for them. It's a complete, total custom job that we're doing on it. So that this image obviously here shows it without the rocker shaft in it, without the rockers on it, because he's simply manufacturing those parts right now. And then, of course, we'll have to order custom push rods for it. Not a big deal, custom, or we can get custom length. We can either order them or we can find the right length. We'll probably be able to find the right length. Anyway, so that part is probably the real trick piece of this. So I get to stay with a little bit lower duration. We're going to trick it into thinking it's got a little bit more lift than it does. That'll maintain my idle vacuum, but it will also it'll also give us a little bit more flow out of this head. We're building this similar to the way that LS motor is set up. Stock LS motors actually have a relatively small cam in them, but the ports flow so well. That's kind of how you make up. That's kind of how you make up for it. The more efficient that you can get the fuel and air in, the better off you are. So porting is obviously important. Port geometry and intake geometry is obviously important. So all those things should help us out here. We should also end up with much better idle quality than we have with the log head. At any rate, I just wanted to go over what we've done with this thing. Stock, it's got the same crank in it. As a matter of fact, the crank was 1010. It just needed to be polished, so we're going to use the stock crank. The deck is at 0, so we've 0 decked the block, so the pistons are level with the deck. We're stock rods, nothing trick. Pioneer rod bolts, didn't put ARP in it. It doesn't need it. It's not boosted. The mains will probably, I imagine Jeff's probably reusing the mains. You don't really need to replace main bolts, especially with 7 main caps. I'll put my balancer on it. It's got a flow cooler water pump on it. I'm going to put, I've got an awesome valve cover coming. Jose Alvarez, thank you. He actually did a group buy on some. They come out of Argentina. That should be here shortly. So we're going to have a nice aluminum valve cover for it. It says Ford Racing on it. It's pretty neat. And of course the multi-port fuel injection. That's this last photo here of the throttle body setup. This is going to fit under the hood. As opposed to putting a 4-barrel on top of here would actually hit the shock tower or the export brace. This elbow will not hit. So anyways, just want to give you guys a quick rundown on the build, some of the problems that we ran into, the head, really mostly around the head. Jeff's got a lot of hours in the head. The machine work was just really terrible on it. The casting looks great. It was cast at Buddy Bar down here in Los Angeles. As a matter of fact, they're well known. They make intakes for a bunch of different manufacturers, real well known folks. So I'm not concerned about the casting at all. It's just the finished machine work was no good, and that's partly why Matt is so hung up right now getting new heads out the door and making new heads. A lot of people have been on the wait list for a long time. That's why he's got to find a shop that, I think he actually found a shop that does the casting and the machine work, but it's just not a priority for them, and it's not a priority for him. So, to answer the question that I keep getting asked, where can I get one of these? How can I get it? The answer is you can't. You can find one that's new original stock like I did, which I was very fortunate, or you could find one that somebody's selling that's used. They're very rare. I'd say probably one a year comes up for sale. I just got lucky. Colin spotted it. I laid out the cash and grabbed it. Just didn't know what the hell I was going to do with it, but I wanted to make sure that we grabbed it as a community, and I ended up using it. But anyways, so that's where it's at. Jeff should be test firing it the next week or two as soon as he finishes up the rockers. It should be running. We'll get it down here, and we're going to do a trip up to see Jeff again. And of course, we'll shoot some footage when we do that. Maybe I'm going to get Jeff to walk us around his shop this time. I was kind of short on time last time, and it didn't work out. But I'm going to get Jeff to show us around. Jeff's a good guy. I really recommend using him. He's a stand-up guy. I've had a couple issues with the motor that's in the car now, and Jeff, no questions asked, took care of it. And it wasn't even anything that was really his fault. But you'll remember that's definitely in some older videos where I had issues with the first head that was on it. But he's loaned me tools that are specialized and shipped them down to me. He's just he's a really good guy, and he really knows what he's doing. And he's probably built more of these 200s than anyone. Check out Jeff at Vintage Engine Works. He's up in Fresno. He ships worldwide, actually. He's shipped to other continents. So anyways, next video, we'll be going up to go see Jeff and pick this thing up. And we'll be swapping out.